this is a TS diagram from the Atlantic Ocean. Okay, so where the so-called CTD instrument was used to measure the temperature and salinity, starting at the surface and then measuring down to a depth of 5,000. In order to know the depth in these diagrams, the depths are actually added as these blue numbers in meters. So you can see a 0. 0 corresponds to the surface. And then you can see 1,000 meters, 2,000 meters, 3,000, 4,000, and 5,000 meters. Okay, and the structure that you find is quite special and different to what you actually expect. Okay, so what is always trivial is that the lightest water sits near the surface, and the heaviest water you found on the bottom of the oceans. And this is what you can see here in these lines. You can see the isopycnals. So low number 26 is here at the top, and when you go to the bottom of the oceans, it's more than 27.8. Okay, so that's trivial. However, the temperature and salinity values can change significantly. So from there, not a simply monotone decrease or increase with depth, you can see particular structures. Okay. In this, you can see that at a depth of just above 1,000 meters, there is a salinity minimum. Okay, and with these features, you can actually identify the water where it comes from, the origin of water masses. And this water, for example, that I just referred to with the salinity minimum, is known as the Antarctic intermediate water. And you can tell where it is formed in interaction with the atmosphere, and you can trace it through the ocean interior. Okay, and then on the other hand here, just introduce you to that little nose type of structure, which has a local salinity maximum. You can see here between 2,000 and 3,000 meters is actually North Atlantic deep water. It's water that's formed in the North Atlantic and propagates through the ocean. This is the driver of the so-called deep circulation of the ocean. Okay, and you can identify and track this water through its temperature and salinity characteristics. Okay, so now another important point is that temperature, salinity in the ocean interior, like say below 500 meters, change only very slowly. So it takes 100, 200 years for these to change. So you don't have to go that often to do these measurements. Okay, in the deep ocean. In the surface layers of the ocean, it looks different. There you get seasonal variations. And so here, these characteristics remain the same over many hundreds of years.